Welcome to another episode of Vibe Coding with Steve and Gene. I'm Gene Kim.
And I'm Steve Yegge.
All right. So the goal is to share with you what we've learned while writing the Vibe Coding book, which is coming out in late September, early October. I'm just so proud of how the book came out. I think it's just an amazingly fun book to read, and it just shows how much we've learned. We've had some amazing adventures, and how Vibe Coding can help every developer integrate AI into their daily work to help them solve problems that they have to solve every day. So the goal is to jump into a section of the book and share some of the insights that made it in, but even better yet, the insights that didn't. And today, I chose a section of that's called "Programming: No Winners, Only Survivors," which I thought was like really funny. And maybe to underscore this, Steve, you and I talked about how we just marveled at how Dr. Eric Meyer, who is one of the most influential figures in programming languages, he influenced Haskell, Visual Basic, C Sharp, the hack programming language at Facebook Meta. We talked about how amazed we were to hear him proclaim that the days of coding by hand are coming to an end. And I don't know about you, Steve. I actually took such incredible solace as we described how, as many advances there have been in climbing up the abstraction ladder with going from punch cards to IDEs, to having structured programming languages, it's still so freaking hard. Steve, and especially to have you validate how hard programming was, I just found so soothing and joyful. And it also made me feel good about struggling with, say, writing a front end app in JavaScript.
Yeah, I mean, come on, let's face it. Programming sucks. A lot of us manage to sort of maneuver our way into a code base that, we know well and we're contributing on it for years at a time. So you don't really have to learn a new build system or a new package manager or a new authentication layer or whatever. But for most of us that are like building out microservices or just like doing lots of different projects and stuff, programming has just gotten worse and worse and worse over the years, right? I mean, it's more powerful. You can do better things. But I mean, we brought it up in the book. The amount of stuff you have to know just to get a simple web app off the ground these days is almost comical. It's like a parody of itself.
Yeah, in fact, we give a concrete example. I remember reading Jose Aguinaga's article, "How It Feels to Learn JavaScript in 2016." I lived that. I wrote my first, it was my second relearning of JavaScript to write a front end app around that time, and it was effing miserable. And we wrote that a typical set of decisions you need to make, whether it's 2016 or now, you need to think about package managers. Is it npm or yarn? Bundlers, is it Webpack or Rollup, which I've never actually heard of? Transpilers like Babel, and there's other ones, and how you do polyfills, task runners, Gulp, Grunt, and that's probably out of date by now. Testing frameworks, CSS processors, whether it's dynamic or static, build tool chains, deployment pipelines. And I loved the fact that, there's a section that we say it's actually worse now because of the DevOps philosophy of you build it, you run it. You also need to learn Docker, Kubernetes, AWS, and Terraform, and whatever cloud service you're using. And there's this ridiculous situation you can get into where you're simultaneously trying to figure out how to center a div element while you struggle with Docker networking issues because your CI pipeline broke after you change a Terraform script. It's funny, not funny, but also not absurd, and also very absurd.
Yeah. I mean, like people say coding isn't the bottleneck. They say, producing code isn't the bottleneck. And I think they're referring to that stuff. All that just grungy stuff that you have to learn or that you have to configure or that you have to get to work together somehow. A lot of the libraries that you just listed off are like incompatible with each other and it's not super clear. Right? I mean, it's just a continually shifting sort of landscape. And JavaScript, we're picking on JavaScript, but you can now take almost any ecosystem or any language, and it's just a total mess. So yeah, these things. The thing is, the AI helps with them too, right? And so you know them all now. That's the beauty, right? Is that programming has gotten terribly difficult, but all of a sudden, practically overnight, all of those things became part of the production of the code by the AIs, which I don't think people realize how historic that is. It's performed a big reset to where programming is now back to easy as it was in the 70s, using very similar looking tools.
And by the way, as I'm reading and thinking about it, it's fun to laugh at right now. But I remember being there in 2015, 2016, trying to figure out what these things are. I mean, they show up in these sample projects. I don't know. I didn't know what a gulp or a grunt was, and I actually didn't know that they were mutually exclusive. And I think I might have even had them running in the same project at the same time. It's really hard. And Steve, I'm wondering. And then TypeScript comes out, which adds a whole nother processing thing, and then you have React, which is sort of JavaScript, but it's actually annotated with JSX. It was effing hard. I mean, it was really, really hard. So, Steve, I'm wondering if you can maybe just take a couple minutes to sympathize with it as someone who's written over 1 million lines of production code over the decades, and maybe describe how it's not easy for you either.
Yeah, look, I am deeply in the school of thought. I'm of the philosophical camp, and I have been for 20 plus years, that code is a liability. Okay. I saw somebody posted a pretty impassioned article about that within the last week or two, and I was like, bravo, right?
Yeah.
'Cause most people and most companies think that their code is an asset, and you're wrong. But seriously, you're really, really, really wrong. Code has weight and inertia to it. And even if you know the code like the back of your hand, um, your ability to make changes to it, regardless of how good your refactoring tools are, right? And they're good, okay, is eventually going to be limited by the sheer size of the code. And I can tell you this because it happened to me. Okay, I have a project that's 30 years old and it's had 60 plus volunteer contributors, many of whom contributed for a decade or 2 decades. It's got a lot of code in it, trust me. And it was super ambitious, and it just became way too much. Everybody at a company, you're all feeling this weight too, and you're all complaining, and dev is always behind, and you're always like, we're fine, it's fine, there's nothing wrong with a lot of code. I'll tell you, I meet people every day that are like, oh, I love code, and your IDE, don't worry about the amount of code, your IDE will handle that. But then we go and we meet companies that have 100,000 Git repos, and they're just drowning in code, and they're like, you got to step back and go, is this really an asset? Because honestly, if you can get it done with less, wouldn't that be better? Because, right? I mean, I don't know. And I think just a lot of people don't really understand how much inertia it has. But it started to drown us. And honestly, it's a double-edged sword, right, with the AI, because it generates a lot more code. And so now we're in a new world where reading code is starting to become critically important and reading lots of it at once. So yeah, I don't know. Gene, what do you
Yeah, in fact, there was actually something that you wrote that I found also very soothing. Which I think the book also explains why some people are reacting so wonderfully to vibe coding. You said because of all these things, we're still mired in more complexity than ever, right? As all these components are changing, right? You have to know everything about everything while everything's changing. And incidentally, this is why many people have chosen to leave coding. It has become too freaking difficult and not worth the effort. And I'm thinking about like Kent Beck, who said, "This is my first time. I haven't had as much fun as I'm having right now in 30 years." He's coding it in the middle of the night for the first time in decades. We've seen so many people building things
Elizabeth,
again.
Elizabeth, what's her name?
Elizabeth Hendrickson, yeah,
Yeah,
totally.
yeah. We've seen so many people who had hung up their hat and not code and said, I'm done coding because of the stuff that Gene and I have been talking about in this episode. It just becomes too much for you after a while. The ROI just isn't there anymore, right? You're just like, am I really going to go figure out what Grunt V3 is? Do I care? And it's like at some point you're spending more time trying to like set up your environment than you are actually like solving problems. And so we leave coding, but they don't become non-technical and they miss coding and they still love that rush of producing, working software. They're back in a big way now because of vibe coding with agents.
Yeah, and so I think we called it level 99 heroes logging back in, right? And at first, yeah, and I think this actually took us astray a little bit in the book because we love talking about the people returning to coding, and so that's not really who the book is targeted at. But I mean, it was just so inspiring to see all these people who made that decision where the juice wasn't worth the squeeze, and they stopped coding and to bring the joy of coding back to into their lives. I mean, that was very much my story. And so we have to sort of readjust the book back to sort of developers who are coding every day. But for me, it's such an inspiring and wonderful data point that these
Yeah.
level 99 heroes are logging back in, building cool things. We saw Adrian Cockcroft building cool things.
Well, yeah,
Famous for the
right.
work
So
on
like
Netflix.
let's just like address the elephant in the room, which is the job market isn't really that great for software engineers right now. And so I just want to reiterate, you shouldn't be scared that a bunch of level 99 programmers are coming back into the job market and competing with you. That's not really what's happening here. You don't have to compete with, Adrian Cockcroft. What's happening is everybody is able to code now.
Yeah,
Non-engineers can write code. We talk extensively about it. Engineers can write better code and more of it, but still, coding is becoming accessible to everybody now. Yeah. And so there's more jobs. There's going to be more jobs. There's going to be more of everything, more, more, more. And your skills as an engineer are going to be incredibly valuable in this new world as a reviewer and a mentor and so on to all these people who are completely new to it and building software. Yeah.
fantastic. And so another way to say that is we are, in fact, Andre Kapathi in his talk to the Y Combinator crew said LLMs represent the largest leap in the abstraction ladder that we've ever seen, right? Because you're coding, you're building, it's being able to specify these things in English, right, in plain language, right, as opposed to a programming language. And that notion of leaping above, leaping higher in the abstraction ladder, is I think appropriate. And he had a really great example of wonderful things that can come out of it, and specifically your story about learning graphics, 3D graphics in the 1990s, where it was revolutionized within years. You want to tell that story?
Yeah, sure. I mean, like, but by the way, I mean, like, Dr. Eric Meyer, right? We started, was it this episode? I think we were amazed that he was so excited by this leap up in the abstraction ladder because he had put his life's work into creating the lower levels of it that were now kind of becoming kind of obsolete. Here's a person who has contributed to some of the most important programming language, research and practice, in the world. One of the top language people who you'd think really likes languages and code, and he does.
Yeah.
And yet he's super excited by this. In fact, he told us that what he was doing a bunch of research at Meta, and they had trained a bunch of models and blah blah blah. And when the
Oh,
LLMs came through, it was like, oh, the professionals are coming through. Get out of the way. The grown-ups are here. And the generalized models performed way better than all their specialized ones.
yeah.
And
In
he
fact, can I
was
tell that story? Just
delighted.
because.
He was delighted. Sorry, go ahead, Gene.
Oh, no, no, no. In fact, it's such a great story. In fact, that the first video clip that I ran through my the program I wrote in 47 minutes. Thank you for bringing that up.
I'm getting you excited, I can tell.
It was such a great talk because he was describing when he was doing his programming language development work beyond just the hack programming language, is they were building AI models to find and fix bugs, and they're making advances. And then he said, then ChatGPT shows up, and he said it felt like we were digging a tunnel with pickaxes and shovels, and these other folks show up with dynamite and heavy moving equipment. And he felt, he said the professional showed up, and we had to get out of the way. And it was just this revelatory moment that these generalized LLMs are better at solving these class of problems than these specialized models that he'd been working on for years with a team of PhDs.
Yeah.
So over to you.
But he was delighted by it, and I'm delighted that he was delighted because
Yeah.
what does he really care about? Does he really care about like adding, a new continuation passing scheme to some language, or does he care about like people solving problems? Clearly, Dr. Meyer is in the people solving problems camp. Yeah.
Yeah.
And so, to that point, I went through a similar thing with computer graphics. I took graphics back at the University of Washington in like 1990s, early 90s, like 90, 91, under Tony DeRose. Dr. Tony DeRose, he's at Pixar. He's a legend in the graphics industry, and he was our professor. And he had us learn computer graphics from the 70s, where it's like you get a raster of a bunch of pixels you can turn on in different colors, and that's your palette. You get put pixel. And so we had to learn how to draw lines and polygons and shade them and then like render them and clipping and all that stuff. Okay. 2 years later, I'm getting ready to graduate. Yeah. And I noticed the graphics, there's several graphics courses, there's new graphics professors, and there's no mention of polygons anywhere. And I was like, I got to take this again, right? And so I signed up again and, took it again. And the second time I took graphics was about 2.5 years later. It was so totally different. It was different. We were all doing animation and like all this fancy like scene graphs and even that stuff is like completely what had happened was it was getting pushed down into the hardware, into NVIDIA hardware. Boy, if I bought some NVIDIA stock back then. And so what was happening was our job was getting eaten by the hardware over and over and over again. And so the schools kept having to teach, being able to teach, but having to teach higher and higher things on the abstraction ladder to where today, well, what does a computer graphics person do? First of all, everybody does graphics. You have modders, right? That are, they're not professionals, but they're making professional quality graphics, physics engines and combat systems and right quests and whatever, using, U Unity and Unreal and things like that, right? It's become not commoditized, but it's become accessible to a much, much larger audience. And the things that you do as a real graphics programmer, unless you're actually working on one of the engines, are much, much higher level, right? You're more like an artist. And so that's honestly, that's where coding is going. I saw it happen over 30 years with graphics, but that's because there was a hardware dependency. Here, it's going much, much faster and much farther up the curve, and it's going to happen over just a couple of years, but it's going to utterly transform, and we already see it, which means jobs will change, schools will change what they teach. And this is all, of course, very confusing because, like, how is it going to change? What are they going to have to teach? Yeah. We tried to make some predictions about that in the book, but still, it's a lot.
Yeah, and in fact, I remember taking a graphics course in about the same time, around 1992, and you had your depiction just brought back so many memories. In the first iteration, I was doing exactly what you were doing. You make teapots, you're creating shaders, you're trying to figure out how to shade the polygons. I never did the second iteration, and you mentioned what the exercises were then, right? You weren't shading polygons, you were making
No,
scenes, you were making
yeah.
animations, maybe.
Yeah, exactly. We would, you'd say, okay, my project is going to be a fiery ball smashing the earth, right? Which is just like so much more interesting than a teapot, right? That's what had happened in 2.5 years, and it was just awesome. And it just
Yeah.
it shows we were able to get more ambitious. We became more ambitious naturally, and it became more fun. The FAFO stuff we talked about in episode 2, right? Do you want to remind people what FAFO was,
Oh
Gene?
yeah, FAFO, faster, more ambitious, autonomous and alone, fun, and more optionality, more swings at bat.
All of that hit us in the graphics industry. And again, it was an inevitable, inexorable change. You couldn't just say, I'm just going to continue being an old style graphics programmer because you'd be unemployed. You had to continually be on this curve of learning the new stuff. And that's where we're at today. But look at graphics. It just got more and more and more fun. What do you think's more fun? Like writing a Skyrim mod or rendering polygons? I mean, come on, it's obvious. I've done both. I haven't written a Skyrim mod, but I mean, I know how they do it. And I can tell you that's a lot more fun. So yeah, we saw FAFO in the graphics transformation, and it's a microcosm of the larger transformation that's happening to programming in general now.
Love it. In fact, by the way, my oldest son last year took like a little 2-week workshop at USC, and they built a games and Unity engine. So they're creating scenes, models, and creating a story, right? Which is a lot more fun than rendering through polygons.
Yeah,
Which,
I mean, we're heading
interestingly,
towards a world where everybody is going to be creating software. That's vibe coding. We wrote the book Vibe Coding for Engineers. If you're listening to us, you're probably an engineer, or engineering adjacent, and all of you will be vibe coding like now. You can vibe code now, but everybody will be vibe coding soon. And it's really similar to how your kids were able to take a graphics. It's not exclusive club anymore.
yeah. Yeah, fantastic. So, I think how about we talk about when vibe coding goes wrong, the dark side of FAFO. I think it's super cool that in part 2 of the book, as we talk about the theory of how these things work in your first vibe coding sessions, one of them is creating a shader with the multiple light sources that
Oh,
takes maybe 3 minutes to do and maybe 2 sentences to write, which is pretty
yeah,
fun.
in 2 sentences you can create something. It's an exercise in our book that's far more sophisticated than my final project was in graphics in the 90s.
Yeah, by the way, I'm not even sure if the polygon shader that I wrote, where you had to compute the normals, worked all the time. I'm not sure if I got an A in that assignment. So let's talk about maybe the dark side of FAFO and some horror stories that we tell to scare each other and to scare all of you. That says some specific, very formative experiences that we had where vibe coding went wildly wrong. And there were 5 specific stories that we brought up. And the first one was from you. It was a vanishing tests. Where's my code? Steve, you want to tell us about that?
Oh my goodness. Yeah. So, look, as Jason Clinton, right, CISO for Anthropic, shared with us at Gene's most excellent forum in April, where we had experts from all over the world. He shared after I complained that it had deleted my tests, which I'll tell you about shortly. But let's explain why first, right? What happens is the LLMs, look, a lot of you online are saying this is not feasible what you're talking about. You can't vibe code with agents because XYZ, they make all these errors. And then they show us the errors that they made, right? It wrote all this code that's wrong. It deleted all this code, blah, 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 and it's wrong. Okay. And our book is setting out to sort of like explain that no, that's just how it works. And you, as an engineer, work within those constraints to take that power that it has underneath it and, and create things yourself. All right. Okay, so with that said, I had a situation where I said, "Hey, Claude Code." I believe it was Claude Code at the time. I said it was writing a bunch of tests, but then it had broken a bunch of them, right? Because it was ported the tests, but they weren't working. Okay, it was a part of a larger test porting project that we talk about in the book, where I learned a lot. But early on, I had it write a bunch of tests, and I was like, port a bunch of tests, and then I sent it to my colleague. And
Okay.
he was like, I'm not so sure, man. I think a lot of the tests might be missing. Okay. So it's actually my colleague who noticed this. And I went and I looked and it was the first time I had been listening to the LLM and it had been telling me all this BS, just blowing smoke up my butt, right? It was just like, we've done XYZ, we ported this, we deleted that, we disposed that, we everything's working. And had I looked a little more carefully when it said we deleted that, we disposed this, right? You have to look really carefully what it's telling you because it will tell you when it's doing destruction. But it's just like it puts all these happy emojis on it and green check. You've
Yeah,
seen,
that's right.
I'm
The
sure,
green
right?
checks.
It looks like it knows what it's doing. It sounds so confident. And so Jason shared with us that it had been trained on a reward function, which is to help you get stuff done.
Yeah.
Okay. But it wasn't trained not to hack that reward function, to redefine done to mean
Yeah.
something else. Okay. And so that's what it does. It's like it needs to get done in the context window and it starts running low on space and it starts doing all of these crazy, making these crazy executive decisions. We have multiple sections devoted to things that can go wrong here. The cardboard muffins, the missing babies, you name it, right? But the one that I started this with was our missing tests. My colleague noticed they were gone, and I found out that they had been deleted weeks before, like at
Right.
least a week. I mean, in AI time, it was
Yeah.
forever before, and that many commits and lots of work had gone into the branch before these particular tests had been deleted. Why did it delete the tests? Because that was the fastest way to get them done.
Right.
Now,
Right.
Claude 4 doesn't do that as much. Actually, it does do it. It's just it
I
does
think
it
60 to 70%
60% less.
less. Right.
Yeah, yeah. So 60% less horrific mangling of your code base.
Yeah. In
Right?
fact, I
So this
remember
is
you texted me that night. It's like I told Claude Code to take care of my tests, and it sure did. It cared for them like Godzilla cared for Tokyo. And I was like, what? Like, I can't wait to hear about this tomorrow. So that story is instructive because these LMs want to be helpful. They want to comply with the instructions, but because of certain limitations, like as you mentioned, the context window, the output context window,
the training.
training, right? It will often
Cheat. It
cheat.
cheats.
Exactly. Okay, so that's number one, and we'll in a future podcast we'll describe specific techniques and mental models like the cardboard muffins, counting your babies, right, to help you counter. These are mitigating controls, right, that help you detect when these are happening.
And also prevent and correct them.
Prevent,
Part
detect, and
part
correct.
three of our book, we'll probably talk the least about part three, but it is definitely the juiciest, meatiest part of the book because it gives you a lot
Yeah,
of really hands-on practical stuff that I do. Well, we both do now, like out of like habit that we've like instilled in ourselves to keep these things on the rails, okay? At the level of stuff we do over a period of days, things we do during the day over a period of hours, like updating all of our plans, and things we do like within, seconds as we're dealing with the agents. It's a really, really technique-filled part of the book.
absolutely. And my goal is let's go through all of them in part three. And and Dr. Andre Kapathy and the Y Combinator talk, and whenever you talk to anyone, like these experts talking about vibe coding, like one of the best mitigations is just shrink the task, right? Instead of asking it to do fix all the tests, how about fix one, right? And as you gain confidence, maybe two, maybe three, right? And to avoid these problems, one of the best mitigations is just ask it to do less.
Yeah, I mean, like seriously, if you like only took one thing away from our book, it would be that you're giving it too much work. The LLM, you're giving it too much work. If it's failing for you, you gave it too much work. You need to scope it smaller.
Yeah.
Okay. And that becomes really difficult if you have a giant tangled monolith.
Totally, totally. So the second one actually is mine. It was the Eldritch horror code base when Fafo dies. And so I might have alluded to this in one of the earlier episodes. I had written a writer's workbench to help with the generation of the book. It helped us with critiquing, draft generation, draft evaluation, and ranking. and a lot of it was to reduce the amount of slinging of prompts. Yeah, I mentioned I wrote my first one as a JavaScript app, my second one as a Google Docs add-on, and I did that in 3 hours, never having written a Google Docs add-on before. And the third one was a terminal interface,
And
sort
by
of
the
like
way,
Claude Code.
Google Docs API is absolutely terrible.
Yeah,
Right. I
it
mean, look,
is.
Google is just absolutely inexcusable. They're, how Tim O'Reilly calls it in shitification.
Yeah,
But, Google has allowed their whole Google's G Suite thing to just not be a platform, not a good platform at
yeah,
all, because they have this like sort of monopoly position. And so if you want to do something like use, their docs system programmatically in a writer's workbench the way Gene did, he had to pull some really, really clever hack get this thing working, and he got it done in 3 hours.
yeah.
It was
It was for the first iteration. Yeah, totally. And so I had mentioned that we ran 70 million tokens through this thing, but there was a point in time, and there was around 20 million tokens where it was super easy to keep adding new functionality. For example, like send it to one model, send it to all models, add more models. It was just amazing. And I used Simon Willison's LLM utility until I couldn't add anything anymore without breaking something. And it was one of the first times that I really looked under the hood and studied what it was doing. And I described it as an Eldritch horror, a giant 3,000 line function with no modular boundaries, impossible to understand, let alone modify without breaking something else. And I mean, just like one thing I want to do was keep a more comprehensive log of the intermediate files of the input prompts, what the model returned, and so forth. And it took me 20 minutes to study the function signature of the inputs. Could not puzzle out. I got into my head 20 minutes later, and I couldn't remember it 10 minutes after that. I mean, it was just incomprehensible. And Steve, you were out of pocket for about 2.5 days. I used that entire time rewriting that one function so that I could, add some tests, shore up and characterize and test what the behaviors I wanted were, so I could change some parts of it in a more modular way. But it literally was one of the most incomprehensible code bases I've ever seen. Right? Was it the
right.
AI's fault?
Let's talk about why it happened, right? It's not the same as the root cause before. The root cause here is that the LLM really can only focus on one thing at a time. So you can't tell it to do two things at a time. You shouldn't, or it'll screw it up. It'll do a half-assed job of both. What was missing here was the elegance pass. Okay. Gene needed to go in and tell it to write elegant code, modular code, well-factored code. He hadn't, and since that wasn't a requirement, it didn't do it. Right. So, I mean, this is a fairly easy one to avoid, but it has to be part of your tool chest of after every bit of code that's generated, you have to go and have it compare that code to the rest of the system and say, are we headed in a bad direction with this
Yeah.
whole system architecture?
And like it's always tougher to put toothpaste back in the tube, to actually partition the system, make it more modular. I mean, that was a tough 2.5 days, but eventually I did get to a point where this is something that I could understand and modify, and I was back on that ramp. And it was really funny, Steve, is I remember texting you. It was like, oh my gosh, I'm exhausted after refactoring this code base, and I was shocked. I was shocked to learn that the program was only 30 days old. It felt like quarters, right? I mean, life moves fast when you're vibe coding. I mean, it was exhilarating, created so much functionality, but it was only 30 days when I went from initiating the project to, this legacy code base that I couldn't understand anymore.
The 30-day-old, they talk about the billion-dollar unicorn, or sorry, the solo unicorn, right? But yeah, what about the 30-day legacy, the 1 week legacy code base? Yeah.
Awesome, awesome. And so obviously, the countermeasures there, Steve just talked about. The third story that we shared was a vanishing repository, which we actually shared in a previous episode. But do you want to briefly mention just maybe a 1 minute summary of what happened?
Yeah, I mean, like what happened was a bunch of code disappeared because it was on a branch that had never been merged to master, and then it was getting cleaned up as part of a hey, clean up all your old mess stuff, right? And so I wound up finding it on an orphan inode, and I didn't lose the code, but it was kind of a disaster, and it was a different kind of disaster caused by the cross coordinating, running multiple agents at once. One of the things that can happen to you is you can be texting the wrong person. Okay, or so you can give the agent some instructions, and you gave the wrong agent the instructions, and it's in the wrong directory, and it's off doing now. It's trying to interpret what you said and do something meaningful with it, and you can wind up having them working in a workspace that you didn't realize they were in, and doing a bunch of work, maybe even succeeding with it in the wrong workspace. So all kind of weird things can happen if you're not paying close enough attention. You're monitoring the work, but not where it was happening. And it
No, in
just
fact, this should be
wound up with a
familiar.
horrible mess.
Yeah, and this should be familiar to many people who have accidentally deleted a file in the state. They thought they were in staging, but they're actually in production. Or you drop a production table and you know there are no backups. I mean, it's the
Yeah.
same sort of oh shit moment, right?
When you're managing multiple work streams at once, those oh shit moments really start to come more often.
Yeah, and so Steve had mentioned in a previous episode that the tools are really pretty poor right now, and so you have to sort of create a lot more mechanisms to make sure you think, to make sure that you're spatially oriented and you are where you think you are.
Yeah, so if you look at my setup, my agents are different color schemes, right? And they're kind of permanently tied. So work streams are tied to colors. They have specific names and they're put in specific directories. I mean, the new tools that are emerging are going to be giving you better and better ways to basically keep these things separate. But it's like these guardrails that they're going to have to put in because it's so easy to have them working in the wrong place.
Yeah.
It's weird.
Let's talk about the next one, which is actually not us, but it was actually Luke Burton, who was also at that amazing
Oh,
workshop that we held in April. And so these digital mistakes in software are bad enough. He had this other amazing story, which we'll talk about more in a future episode. But Luke Burton, someone I've known for almost a decade, he spent 2 decades at Apple. He's now at NVIDIA, and his hobby right now is playing with these CNC machines. So these are the kind of the metal grinders that do precision grinding and
cutting. They're fancy cutting tools,
cutting
right?
tools. Yeah, yeah, yeah. In fact, I think all of the MacBook aluminum cases are all now made by precision CNC machines. And he talked about how he was using it to create a new firmware uploader. And the text that he sent us was, how he was doing a whole bunch of great work, but something scrolled by so fast, he almost missed it. I was one alt tab away from having to factory restore the machine, which would involve getting access to the rear panel. And this machine weighs 100 pounds. So it would have wiped the SD storage device on the card. And so just talking about like how vigilant you need to be. And sometimes it's detecting a unit test disappearing. And sometimes it's actually doing kind of destructive operations where you don't want, it has tremendous consequences.
Yeah, this is not a self-driving car, right? A lot of people make the mistake of thinking that this is like what Tesla promised in 2013 and still hasn't delivered. This is level 2 FSD, right? You have to be like eyes on the wheel, hands near the wheel, like watching the thing, or else something that's just in the torrent of text that's flowing by, something that go by that's very, very serious. Yeah. So you don't turn your brain off when you're doing this. You're paying attention to what they're doing. And if necessary, you scroll back and just review it all to make sure that they didn't do something that's going to make you like have to drive out to the warehouse and reset the machine.
Yeah, actually, there was an apocryphal story, which is actually mostly apocryphal, in the 70s about like how when in like Winnebago's when the first cruise control came out, people would actually hit cruise control and then go back and take a nap. And this is actually showed up on Snopes and other kind of myth busting things that it was kind of busted as an urban myth. But it actually happened a couple of years ago where a woman in the UK actually did that and wrecked her,
Tesla?
trailer.
Oh, her trailer. Because
Yeah.
people were doing it with
Uh,
Tesla self-driving too.
exactly. Yeah, I think it was like what do they call them? Caravans, like the trailers you put in back. All right, one last story. We call it the disobedient chef when the AI ignores direct instructions. And this one had to do with the Trello authentication um, project I was working on, where one of my agent coding aha moments was having the agent solve this authentication problem, and it solved in 45 seconds as opposed to 45 minutes of me copying and pasting things for the AI. But kind of one of the things that happened was that all the prompts for this particular program lived in a resources directory. So in a Java or Clojure program, you don't want it to access it through the file system. You want to have it access it as a resource so that it could be used as a library. And despite all my explicit instructions, prompts must be only accessed through the resources API. It silently read it as a file, right? It slurped it in, and so it's like one of these problems where the program worked, but had I not caught it, it's like one of these things that sort of is like now a minefield that you just place for yourself, and it would fail, when I'm running it as a library. So the lesson here is that one of the things that AIs aren't good at, another thing that AIs aren't good at is instruction following. And so especially as you saturate the context window, as you put more and more stuff in the context window. So again, a lot of the people have noted, that AI doesn't work. Yeah, it's true that AIs don't follow instructions all the time, and yet it is something that you can mitigate again through prevention, detection, and correction, testing, and verification. Yeah. So the last thing I want to bring up here is that it is true that people have noticed that AIs can screw up coding. And these are instances and examples that we've had in our own personal journey that we write about in gross, embarrassing details in the state of DevOps research, which turned into the Dora research at Google Cloud. They had an interesting research finding last year that really caught my attention, which was that they found that as you increase the use of generative AI, you got worse stability and a slowdown in throughput. Right. In other words, the code got worse and you go slower. And on the one hand, part of that you could say kind of validates kind of some of these horror stories happening in production. But the reason why you and I think, were offended by it, we called it the Dora anomaly, is that it doesn't properly show that the other side, which is that used well, you can get mammoth increases in productivity, right, and satisfaction and happiness. And so this is the reason why you and I got involved in this year's study, and the survey is going on right now, which you should take. And the goal is really to show, what needs to be in place, to do vibe coding well. And if you don't have those in place, you're going to have a bad time. Any reactions on this, Steve?
Yeah, I mean, this stuff is, I mean, it's dangerous. It's been compared to fire or steam or electricity, right? It's a new power that we're learning how to harness, and it's not a reliable one. But we're engineers, and engineering is fundamentally about turning unreliable forces like fire and steam and electricity into like reliable things, right? So even if the LLM stopped improving today, which they won't, even though some of you are hoping they will, but even if they didn't, it's out, the cat's out of the bag, right? We put engineering around this, and it's the new way to code.
Yeah. In fact, one of the lines I love in the book is that even if AI progress stopped, we are so much better off than we were a year or 2 years ago. I'd be so grateful. Even if AI plateaued for years, I would never go back to coding by hand again.
Yeah.
Yeah. So, Steve, so that concludes this episode. So, we're talking about part one, which is still about why vibe coding matters. Part two is about the theory and first steps. Part three is about the actual practices of how we modify our inner, outer, and inner, middle, and outer development loops. And then part four is about going big. All right. What do you do when you have teams and team of teams all using these amazing technologies? So, with that, I think that concludes this episode. Any final words, Steve?
Yeah, I mean, we shared some horror stories, and we don't want that to scare you away. We want you to come in with eyes wide open. There are mitigations for all of these things, and you can find them in our book.
Right. Pre-orders are now available on Amazon, and we'll catch you in the next episode. See you then.
See you then.